negotiator. So currently head 2, version 2, head version 2 include this one. However, many of the current production system, current running system in the industry, they are still use the version 1 for safety reason. So it's not, the release, the new version is already released, but not many production system adapt the new version, so they are waiting until it's stabilized. The main difference between version 1 and version 2 is the resource manager. Actually, the map-reduced system, we do not say map-reduced is the program language. Okay? It's a system that includes many components like the API, program API, or the something others. One important part is the resource management, because that's the key part of the map-reduced programming compared to the traditional parallel programming. Okay, you don't have to worry. User want to be free from the resource management. How many nodes are available, which node is good, which node is not, whether you need to transfer or how to communicate with the coordinator. That part is a resource manager. However, in MapReduce 1, at the version 1, MapReduce is included in the MapReduce, the system, which means MapReduce programming is running on only Hadoop, the distributed file system, HDF system. So they want to separate this part, the resource manager, and this version 2. Which means even you can use the MapReduce, the programming on non-HDFS. Okay? So that is the version 2, but we have the good news is even MapReduce, the version 2, can run MapReduce version 1 source without modifying or without compiling. So we are going to use the MapReduce version 1 in this class. So what is the job? Is a full set of programming your project. Okay? Because the task will be used for later. It's a slice of the single network or the reducer. So which means one job, a job has many tasks. Okay? That task includes the network and reducer. Also, there is the task attempt. Sometimes one task can be failed. If job failed, your entire project is failed, you need to run it again. So which is not happen in the company. So in case when task is failed or slow, you can try another task attempt. So because of the speculative execution speculation of the MapReduce, if the MapReducer believes that this job is too slow in this node, you can try another task. It's the same task. They compete. So if this one is finished earlier, you can take the output of this. If this one is later, it's catch up, so finish earlier than this one, then MapReducer will take this one. Nothing to lose, right? Because it's available resource. Do I need to take care of such a thing? No, it's automatically by the MapReduce. So, to understand the mapper, this is a very, very high-level code, so don't worry about the syntax yet. Yes?
When we say the task is failed, it means the node is failed or...
Yeah, sometimes node can be failed, which means if the entire node is failed. Yes, the naming node definitely know which node is not available. At the time, the naming node will create with the MapReduce resource manager that if this one is working for the block 2, then you can select another node of this one. If there's no available block, for example, you can even Okay. So mapper, as you can see, is a key and value. Also key and value. Okay. So from the input, you need to make the key and value. Output of the mapper is intermediate key and value list. Okay. So that is the main job of the mapper. We will see some details about it. Somebody said the 99% of the map reduced programming is how to define key and value. Okay, input and output. Sometimes we need to have one map reduced programming. Then next map reduced programming. Output of this one will be input of the next map reduced. And sometimes you need to decide, depending on the output of this, another map reduced, another map reduced. This is called workflow. So there's another component in header that is called USD to control workflow of this.
So when we got the output, but we can go back.
No, you don't have to back because the output of the map reducer is an HDFS file.
Yeah.
That can be input of another map reducer. Okay. I know right now it's hard to imagine what is the input of the map and what is the output of the mapper and what is the intermediate, the key and value, what is the input of the reducer and what is the final output. So, but this time focus on what is the main concept of the map reduced programming. Then once you run the map reduced programming with your hand, then you may understand for the process of the map reduced programming. So for example, what is the job of the mapper? Sometimes the mapper manipulate the key and value. Okay? For example, here we don't want to consider, so not case sensitive. So we don't care the lowercase or uppercase. So we want to change all the alphabet as the lowercase. At that time, you can apply such a uppercase function in the mapper. Okay, so manipulate the key and value. So you can, in this, the mapper, if you apply the, for example, uppercase or lowercase, whatever. So if you apply the uppercase, it will be like A, N, Q, done, like this. Okay? So that is one of the jobs of the mapper. So mapper needs to manipulate the input key and value. Sometimes I want so input from the input, so you will get this one, but I need to separate the value part by the alphabet. Okay, letter. So in this case, output of the mapper is a full E, full A, full R, something like that. Okay? You can do whatever you want. This is not the example of this. Okay, don't be confused. But in mapper, you can manipulate the key and value. Even you can separate the key part. Okay? Depending on what. Your business word, your requirement. Okay?
For each of this question, not Japanese. Pseudocode, is this a pseudocode?
Yeah, this is just a pseudocode. Okay? You need to implement it. If you want to do this one, you just implement. Some of the functions are provided by the map reducer. If not, you need to implement by yourself. For example, this one is implemented not map function, but any images. So you need to implement in it. Okay? You need to implement this. For example, the prime number, okay? For example, if this is a prime, you will keep, otherwise, no. And this is the, for example, letter. How many letters? Okay. Length, you can consider length. You can apply the length function for this. Then, reducer will collect all the intermediate key and value, then combine. When you combine it, it's not just the sum of the values are just one example. Okay? You can do whatever you want in the reducer. You need to implement it. Okay? And meanwhile, before we send each mapper send the data, key value data to the reducer, there is another step which is known as the shuffle and sort, which means the intermediate key and value will be sorted by key. Okay? So it will be sorted by key, then reducer will collect the sorted the information by the key from each mapper. Then they will combine. So for example, this is the intermediate output of key and value from the mapper. Then reducer will sum up the all values. Okay, so you need to implement such a. So somebody use only the sum. Why there is no? Is there any other way? Yes, you can do that. If your business logic is multiplication, you can multiply by the same key. Okay? Even if your business logic is combine the bar and foot together, yes, you can do that. Okay, you can create this new key. Because you don't know, this one may come from mapper 1. And this one comes from mapper 2. So you cannot do such a job before that. Okay? So you can implement such a business logic in the reducer.
So we need to develop the target.
Yes.
Function that.
Yes, you need to create a function.
Yeah,
Depending on. So main part is how to manipulate the key and value. Okay, using the existing function, or sometimes you need to implement by yourself. Okay. So in this case, it's just actually this is the intermediate key and value. Then reducer will actually separate bar 1, bar 100, bar 77. This is the output. If you want. Okay. Yes. Yes.
Yeah, excuse me. Can you explain something like in real example that?
Yes. After I go over, I will use the word count to explain overview of the real example of the map reducer. Okay. So this is the real example word count. So we write the word count is kind of a hello word in the map reducer programming that I already introduced. So you know what is the word count right now. Okay, so according to the previous slide, we need mapper and reducer. What is the mapper actually of the word count? Just a
Counting every.
we need the intermediate output of
Yes.
From programs.
yes. So for each block, for each block of the input file. So for example, we have the foo.txt file that includes a bunch of words. It's the Shakespeare, the novel. Okay. So how many words? It's 100,000, 1 million of words. We try to count the how many words per dictionary. Okay. To do that, the mapper actually read, extract the word by line first, then separate by word. Then for each word, we will assign just one. How many occurrence? For each is one. What about 1A1? We do not combine yet. The reason is that I already explained. If we combine, this one's overhead. Then
So
too many.
it
Just
is
as
wrong.
it is. That is the reason key is what? Word. And value is one.
What I mean.
Word one. We have same number of key and value pairs as what? The number of word in the input file.
For example, hello, one.
The hello world is hello one and word one. And this one is one, the one of one. We don't care whether the keys are the same one. Yes.
Hello one and hello one is which one does the block?
Not block is by word.
Just
Word. First, I will explain with the source code. Why? But you need to keep your mind. So it's the first mapper. Word count, our mapper should do the emission. Emission means word and one. Key and value. Then after we receive all of this word one from all the mapper, the user will actually sum of the value by what?
Key.
Same key. Okay? And that's it. That is the word count. So we will see that logic with the real data. So for example, our input, our file has the two lines. Okay? For example, two lines. So this one is the offset. And this is the content. Actually, it's a new line character. New line character, actually, the header process line by line as a keyboard. Why? The header has been developed to process, to sense the data or log data. When you create a log data, so think about the print, something in your code. For each event, you have new line character, right? So it's line by line. So when you extract when you read the file from the mapper first time, it will consider offset as the key and one line as the value. Do you want this one? For this? No, not yet. We need to process in the mapper. Okay? How can we process? Separate by space. Space. So we will and ignore some other special character. And so this is the key. This is the key. This is the key. What is the value? 1. 1. That is this one. So this is the output of the map. Will be input or reducer. It's an intermediate key and value. It's not yet. Yes.
It looks like the key is the same one. How it's not, there's no confusion for the.
Nice. Where's the same?
I mean.
So this is the same, but
I mean, that is one, and set is one, cap one, everything is one.
one is a value, not key.
Okay.
Right hand side, don't be confused.
What
The key is not always the number. Okay, it can be sometimes offset, it can be address, it can be entire line, it can be word. It doesn't matter. Okay? Yes. Also, it's not primary key. Okay? It's not primary key. It's nothing but key. Okay? To identify this key and pair. Okay? Yes.
What's the benefit of the value? And we can change it, for example, for 2 or 3.
If you want to change it 2 or 3, you need to consider the how many over here.
Yeah.
So you need to memory, you need to process, you need to additional resource.
What benefit is it?
Advantage, you don't care. You don't have
What's
to
the
do it.
benefit then? What's the benefit?
Later you will consider.
Okay.
Okay? So that is the different from other program
So
languages.
this step we don't care about.
Yeah. Think about you have the 10 millions of this data. You to count already you need to 10 millions of the data. Also, you need to communicate with the next node. Okay? how many nodes do you have? And if you have the 1,000 nodes, it's 1,000
Alright.
factorial, the complexity is much more complex. Okay? So that's the reason in the mapper, main job of the mapper is not the final output, it's to simplify, which means distribute the job. Okay? So this is our expected output. And intermediate data, when you send the reducer, and I explained the one time, before you send this data to the reducer, we need to do shuffle and sort. Shuffle and to reduce the job of this one, you can sort the data from here, sort by one. Key only. Okay? So which means A, R, D, V, L, K, and can map. At this time, how many sets? Because it's a sorted, okay? Sorted, it's not a big deal to combine as an array. But we do not sum. Why? We don't know whether the reducer will sum up or the multiplication or division. We don't care. Just the data as it is. Okay? Then send this one to the reducer. What is the logic of the reducer? What is that? Reducer is the sum of the value. So that's the reason it's the sum of the value. So finally 4. Okay? This is the basic idea of the mass reducer. So as one of you guys already asked, so this is the formula of the entire map reducer. So because you need to shuffle and sort and the reducer need to get all the data, yes, it can be. At that time you need to think about the multiple reducer. Okay? Sometimes if your business logic is simple, you don't have to have reducer. There is a map reducer programming without reducer. So final output of the mapper can be final output. Okay, that's also possible. Yes.
We have like you mentioned before, we have like a map reducer which will be emitted to another map reducer
Yes.
and so on. You could have like data dependency, right?
Yes, so that is a reason to manage such a flow of the job. You better have a separate component to control such whether the map reduce one will be executed depending on the job and the data output of the map reduce, something like that.
But I mean like a different solution, like when many clients are reading from the same file, maybe the one file, maybe one mapper hasn't finished yet, and other mappers will finish it. So the client cannot read the data, right? It has to be locked or something.
No, you can read as many jobs as possible because it's a read-only. It's a read-only data. Yes.
That's right. That's a problem. You have to
So writing until you have the output of the map reduced, there's no way to read
read
the
no
output.
problem, but write there will be problems.
Yeah, you can write the data, but once your writing is done, then the map reducer can read the data output of your map reducer. Also, when you have the mapper 1, mapper 2, mapper 3, you have the reducer 1, 2. Mapper need to contain all reducer. And this one also. This one also. Why? Because we don't know which data is going on, right?
It's like
So we need to
it's like correction data.
Yes, you need to contact. Each reducer need to contact all mapper, then collect all the data. Then also, until all mapper is done,
Cannot reduce.
the map reducer cannot start. So once all member, it doesn't make sense, right?
Yes.
So however, you can transfer the output of mapper even though your job is not done yet.
Yeah.
Okay? So sometimes it is allowed. So we will see monitoring system. Sometimes the mapper is 70%, 80%, you can see for each node. However, sometimes you can see the reducer is the something percentile, the 10%, 20%. That doesn't mean reducer is starting. That means they receive the job. Okay? Once they receive entire the output of the mapper, then can start the reducer job. Okay. Sometimes it can be bottleneck, so you need to consider the more the reducer for better performance. So as we have seen before, if one of the mapper is slow, then it can be transferred to the another one. It's called the speculative execution. You don't have to worry about it. The map reducer system will take care. But when you monitor, when you watch your job, okay, because sometimes the map reducer job takes several hours, so even the day, so you want to see how much is done. Okay, at that time you can monitor using what? Web browser, because it's based on all the communication TCP/IP. So using the HTTP protocol, you can actually see the example data. Once we will use such a command, don't worry right now. Don't worry about that right now. I'd like to have the